Okay, so continuing the question, area between these two curves, we find that by setting this expression equal to this one, because these are both expressions for y, we find when the y values are the same, and what we get is the x values of which y values are the same, which would be 0 cube root of 2, so that on our picture, one graph looks like this, one graph looks like this. So we have cube root of 2 here on the x-axis, and of course 0, and the area will then be the integral from here to here of the upper function minus the lower function. So the upper function is the x squared plus 4, so it'll be the integral from 0 to the cube root of 2 of x squared plus 4 dx minus the integral from 0 to the cube root of 2 of square root of 2x dx, which is of course equal to the integral from 0 to the cube root of 2. It get hard to read these cube roots, but we know what this is supposed to be. It's even worse. Of x squared plus 4 minus the square root of 2x. And it's 2x plus 4, isn't it? We were about to get nonsense. I was about to get nonsense. What you're getting looks pretty good. Okay, so the way I want to write this out is I want to put all this inside of a single integral. Because I'm subtracting integrals over the same interval, of course I can easily do that. Okay, so what we get then is x cubed over 3 plus 4x minus the square root of 2 times 2/3 x to the 3/2 plus 4x, all this evaluated between 0 and the cube root of 2. Try to get that cube root clear. It's a little monstrous. But there we have it, right? Okay. Now, I wonder if we could make an estimate. Okay? Yeah. It's always good to make an estimate. Okay? If these are representative curves, the area of this rectangle here is what? Well, the height is 4. The dimensions of this rectangle are 4 by the cube root of 2, right? And 4 times the cube root of 2 is pretty close to 5. Okay? So rectangle area four times the cube root of 2, which ought to be obvious. And since you corrected kindly my error in calculating cube root of 2, which I thought would be around 1.23, it's 1.25, or very close, which is just 5/4. Multiplied by 4, you get 5, right? And we're just doing a ballpark. So that's about 5. Now that's the area of this thing, so what's the area of this little slice? Well, the area of this little slice looks like maybe 1/4 of the area of this, right? Okay? So I estimate an area of very approximately 1.25, okay? Now that's not going to be exact because I'm 90% sure this is not, I'm even surer than that this is not going to come out the cube root of 2. Just because you got a square root of 2 there, however close it might be. Okay, so we do the arithmetic, okay? The cube of this is, of course, 2 cube of course, the zeros are all going to give you, at 0, we're going to get 0 for every term, right? So we just evaluate at the cube root of 2. Okay, well, that's going to give us 2/3 for x cubed, and then it's 4 cube root of 2 minus the quantity square root of 2 times 2/3 times the cube root of 2 to the 3/2. Okay? Well, that's 2 to the 1/3 to the 3/2, right? So that's going to end up being 2 to the 1/2, or the square root of 2. Okay? Oh, maybe it's going to come out pretty close to the cube root of 2. And then it's going to be plus 4 cube root of 2, all that in the parentheses, and I don't know why I closed that parentheses, except I was being careless, okay? So, square root of 2 times square root of 2 is 2, that's 4. So it's kind of fun to just go ahead and do this. Of course, we do it with the calculator. Then we got a 4 cube root of 2, and then we have minus 2 times, the square root of 2 times square root of 2 is 2, so that's going to be 4/3. And then we'll have a 4 cube root of 2, and we expect the 4 cube root of 2 to subtract off because it came from the 4 here and the minus 4 here. And we could have actually done the integral by simplifying this a little better, but okay. And that equals what? You got 2/3 and minus 4/3. So I'm getting minus 2/3, so something's wrong. Okay, so let's see if we can find the error.